Hi there. In this video, we will discuss how to automate the onboarding and network plumbing of your BigIQ devices using the declarative interface Declarative Onboarding provides. We will also take a look at how to accomplish this using BigIQ. So what is Declarative Onboarding? Declarative Onboarding, or DO, is an F5 API that provides a flexible, low-overhead mechanism for declaratively configuring the network plumbing of the BigIQ, everything from layers 1 through 3. This includes licensing and module provisioning, network plumbing such as VLANs, self-IPs, and more, as well as clustering, adding or modifying user accounts, and much more. Declarative Onboarding is a part of the open source F5 automation toolchain, which also includes Application Services 3 extension and telemetry streaming. Declarative Onboarding uses a declarative model, meaning you send a file containing the entire configuration you want to create using one single REST API call, rather than sending a series of individual commands. The declaration is written in JavaScript object notation format. DO is an API-first approach built for automation, and so it really simplifies the integration with CI/CD toolchains and brings users in alignment with a key DevOps practice known as infrastructure as code. Now, let's dive straight into the demo. In this demo, we're going to configure our BigIQ using Postman as our RESTful API client. The first thing we'll do is send a GET request to the declarative onboarding /info endpoint to view information about the DO version and schema. I've already installed DO in this BigIQ, which is a pretty simple step. See the documentation on Cloud Docs for more information on this. We can also send a GET request to the declarative onboarding endpoint to see any previous existing configurations. Since this is a fresh BigIQ, there is no previous existing configuration, and that's why we receive an empty response. If we navigate to the BigIQ user interface, we can visually confirm that this is a new BigIQ. It's got the default hostname and nothing is licensed. Now let's license, provision, and configure our BigIQ using Declarative Onboarding's simple yet powerful declarative interface. In this first example, we'll configure a standalone deployment. As you can see, I've got a few configuration objects defined in the JSON declaration. We've got our hostname, licensing information, DNS and NTP configuration. We're creating users with role-based access control, and we've also got our module provisioning and VLAN and self-IP configuration. Before sending this declaration, let's take a look at how we can validate the schema of our configuration when creating and modifying declaration files. You can use an IDE of your choice, but it's recommended to use Visual Studio Code. Open up your declaration using VS Code. At the top, simply add the schema property with the value of the schema reference link to the F5 Network's GitHub page. Once you've done that, you can see a few squiggly lines representing some warnings or errors if you have them. To view all of them, you can navigate to the View Problems to inspect and fix all syntax errors and validate our configuration schema before sending the request. And since this is a declarative interface, we don't really need to worry about the ordering of the configuration objects. It's also important to note, when using declarative onboarding to configure your BigIQ, the source of truth is the DO declaration. It's no longer on the BigIQ. So once you use DO to configure your BigIQ, you should continue to make changes using DO and avoid out-of-band changes. So now let's actually send the declaration now that we've confirmed that there are no syntax errors. Once we hit send here, we receive a 202 response, meaning that the declaration has been received and it's being processed. Since this is our first time licensing and setting up the network plumbing of the BigIQ, this usually takes a few minutes since the system has to reboot. So we'll send a few GET requests to monitor the state, and once we receive a 200 OK response, we can navigate to the user interface to visually confirm the changes. Now that we've got our 200 OK response, let's navigate to the BigIQ and check out the changes. As you can see, we've successfully made the changes desired. The hostname has changed, the system is licensed, and we can see our VLAN and self-IP configurations have been made as well. Now let's take a look at how declarative onboarding integrates with Ansible. F5's integration with Ansible is superb, and there are currently over 170 F5 Ansible modules covering most, if not all, use cases. There's also a BigIQ_command Ansible module, which allows users to run TMSH commands via Ansible. I won't dive into all the details here, but if you're interested in learning more about F5's integration with Ansible, please visit f5.com or Cloud Docs, and I'll also post the appropriate links in the description below. So let's just take a quick look at how we can configure our BigIQ using declarative onboarding and Ansible. Now you might be wondering, why would I want to do this? Why not just use Ansible if there are so many modules covering the use cases? Well, the benefit of using Ansible is that it's a part of a large vendor ecosystem. So you can use Ansible to manage and automate configurations of multiple platform types within a data center. However, Ansible is imperative, meaning it requires knowledge of which BigIP modules that need to be run and in which order. The benefit of using declarative onboarding or any of the tools in the F5 automation toolchain via Ansible is that you can automate your F5 configurations in a declarative fashion while using it with a tool like Ansible that can be used for other technologies in your stack, thus reducing tool sprawl and reducing complexity. Ansible is also great for templatizing BigIP configuration tasks via playbooks and roles. So now I'm on my Ubuntu box, and here you can see I've got a simple Ansible playbook, and for this simple example, I'm just going to be using the URI module. However, it's recommended you use the atc_deploy Ansible module. The declarative onboarding declaration file contains the same contents as our previous example, and we're just sending it with Ansible. So I'll run the playbook, and since again this is the first time that we're configuring and licensing the BigIP, it takes a couple minutes because the system has to reboot. So I'm going to go ahead and fast forward this part of the clip, and we'll return once we receive a 200 OK response. After waiting a few minutes, we can see it's successfully completed, and we can navigate to the user interface to visually confirm the changes. For our next example, let's see how we can use declarative onboarding to configure and deploy a cluster of BigIPs for high availability. The first thing we're going to do is send a GET request to the declarative onboarding/info endpoint to view information about the DO version and schema. We can also send a GET request to the declarative onboarding endpoint to see any previous existing configurations. Since this is a fresh BigIP, there's no previous existing configuration, which is why we receive an empty response. If we navigate to the BigIP user interface, we can visually confirm that this is a new BigIP. And we'll do the same for our second BigIP. Now let's license, provision, and configure our BigIPs. In this example, we will configure a cluster of BigIPs. As you can see, I've got a few configuration objects defined in this declaration, most of which you've seen before. I'll briefly discuss the new configuration objects that are specific to the clustered configuration. So here you can see we have the config sync class, which contains properties responsible for propagating BigIP config changes to all of the devices in a device group. The next one is failover unicast class, and this unicast self-IP is the main address that the other devices in a device group use to communicate continuously with the local device to assess health of the device. The next one is the device group class, and this is a collection of BigIP devices that trust each other and can synchronize or fail over their BigIP configuration data. Here the owner parameter value means that the first object in the members array is the owner. The next is the device trust class, which establishes trust relationships between BigIP devices on the network through mutual certification-based authentication. So let's actually send the declaration now, and we have to submit a declaration on each device in the cluster. It's important to note that all BigIP devices should be on the same BigIP version. Once we hit send here, we receive our 202 response, meaning the declaration has been received and is being processed. Since this is our first time licensing and setting up the network plumbing of the BigIP, again, it's going to take a few minutes because the system has to reboot. So we'll monitor the state by sending a few gets, and once we receive a 200 OK, we can navigate to the interface to visually confirm the changes. As you can see, we've successfully received our 200 OK, so let's navigate to the BigIP and check out the changes. Now the most notable change here is at the top left. We can see that it says in sync, meaning we have successfully configured the cluster deployment. By navigating to the devices, device group overview, we can see more information. You can also see that the hostname has changed and the system has licensing information. And we can see that our VLAN and self-IP configurations have been made as well. In this next example, we'll take a look at how to use BigIQ to license and configure a BigIP using declarative onboarding. So let's say you have an existing BigIQ centralized manager for your BigIPs with a pool of F5 licenses. You can reference it from the declarative onboarding declaration file in order to license your BigIP devices. You can also use it to provision modules, configure all your network plumbing, and more directly from your BigIQ. In order to use this, however, you must have a pool of BigIP VE licenses and a BigIQ version 7.0 or higher. Let's take a look at how we can achieve this. We'll use Postman as a RESTful API client. The first thing we'll do is authenticate to the BigIQ using token authentication, and we'll store the contents of that token into the F5_token variable to use for subsequent requests. We can send a GET request to the same endpoint you've seen on the BigIP, the declarative onboarding/info endpoint, to get information on the DO version and schema. Now let's take a look at the declaration we're going to be sending. By now this should seem familiar. Most of this declaration isn't new to you at this point. It's the same declaration as before, but since we're sending it to the BigIQ to license our BigIP, there are some additional configurations that I want to highlight. The first is the license class, which includes licensing information such as the license type, in this case which is license pool, the name of the license pool, and some other information. The second is the target device information, and this part will vary depending on your use case. But for this demo, I will include the device target information. The rest of the declaration includes information seen in previous examples, such as provisioning, DNS, NTP, VLAN, self-IPs, and more. Let's go ahead and send a declaration. We receive a 202 response, meaning it's processing our request. We can send GET requests to the same endpoint to get updates on the process, but since the system has to reboot, this can take a few minutes. Once we receive a 200 OK response with a success message, we can navigate to the user interface and confirm the changes. Here in my BigIQ user interface, we have our BigIP, which was licensed by BigIQ and configured using declarative onboarding, and it is now ready to accept application service configurations. If I navigate to the BigIP user interface, the most notable change here is on the top left, where it says Managed by BigIQ. One last thing I want to mention before we wrap up is that there's a Docker declarative onboarding container that you can run and use to send declarations to the BigIP to accomplish what we've demoed. We've done a lot of demoing, and as you've seen by now, most of the declarations you create and send are similar, with some additional configuration depending on what you're trying to accomplish. For more information, please visit clouddocs.f5.com. And that is the end of our declarative onboarding demo. Thanks for watching.